All right, so functions and relations really are the tools of math, where we solve equations, we do all these other things, but the main thing is we're working with functions. So your first, and functions kind of come into kind of a main idea and kind of a sub-idea. So the first one, a relation is a pairing of numbers so on the first line, a relation is a pair of numbers in one set called the domain. So your second line is domain. And we pair those numbers with numbers in another set called a range. So we take numbers from one set called the domain, and we get numbers in another set called the range. And usually we think of the domain as the x's, and we think of the range as the y's. The domain is what we plug in, the range is what we get out. A relation, so on the second line, a relation is represented as ordered pairs. So it says that on the line. X, Y. And in this case, the domain, that's our next blank, is the X values. And the range is the Y values. So we're just restating what we said up here about the X's and Y's. All right, everything we wrote down is up here. Manny, sit down. Manny, everything we've written down is up there. Have a seat. So, when we talk about functions, we're talking about points in the plane, an x and a y. We think of the x's and y's as the points. The domain, the x values, that's what we plug in. The range, the y values, that's what we get out of our function. And we can also represent a relation as an equation, or by an equation. So our relation is a pairing from the domain to the range. A relation is represented as ordered pairs, x and y. The domain is the x values, the range is the y values. And we can represent the relation as an equation. Now at the top of that first function, the first section, a function is a special type of relation. In which each value in the domain is paired with exactly one value in the range. And that is an important thing about functions. Each domain value has exactly one range value. And the way we can see that in our ordered pairs, I'm going to add a little thing here. You might want to put it towards the edge of that top of that first section. We have no repeats in the x's. So no number repeats in the domain. So a function is a special type of relation where we have no repeats in the x's. All right, so let's look at an example. So down below we have a couple of examples. So for the examples, it says we want to identify the domain and the range. That's part A. Part B is represent the relation with a mapping diagram. I'll show what that is in just a second. And we want to know, is it a function? So the first one, we have the points. So the little braces means this is a set, a group of points. 3, 1, 0, 2, 1, 1, and 2, 4. So those are our points for this relation. Well, the domain, for part A, the domain is just the x values. So the domain is the set. I'm going to do that in blue. 3, 0, 1, and 2. We're just picking out the x values, and I'm going to put them in order. 0, 1, 2, whoops, need -3 first. -3, 0, 1, and 2. Those are my x values. The range is the y values. So that's going to be the set. 1, 2. We have 1 again, so I'm not going to write it again. And 4. This is the domain in blue. And the red values are the range. Now part B, the mapping diagram, just means we're going to put our x values and our y values in a column. -3, 0, 1, 2, and 1, 2, 4. And we're going to draw an arrow for these points. So -3 goes to 1. 0 goes to 2. 1 goes to 1. And 2 goes to 4. This is what we mean by a mapping diagram. We just use arrows to show where the x values go to, which number the x values go. And for part C, is it a function? Do we have any repeats in the x's? Do any numbers repeat here? Which one repeats?
1.
In the list here?
Oh, no.
Does 1 show up twice? Right, there's the ones repeat in the here, but do any repeat here? No. So this would be yes. It's a function because we have no repeats. In x's. And if I look here, I don't have any number that's the beginning of my set of points more than once. Yes?
So a function has to have repeats in the x-axis in the table?
No, a function cannot have repeats in the x's.
Okay.
A relation can, but a function cannot. All right, let's look at another one. The next example. This time my points are 4, 6, 5, 1, 7, 2, and 5, 2. Oh, what do we see right away? I have a 5, 1, and I have a 5, 2. So I have a repeats in the x. So that means part C is going to be no, not a function, because we have 5 repeats in x's. Because I have a 5 here and a 5 here. So I have a repeat there. Well, my part A, my domain, I'm going to say D for domain, is just a set of x values. So that's going to be 4, 5, and 7. I'm not going to list the 5 twice, but we can see that it shows up twice here. And my range is just the y values. So these values. So that's going to be 1, 2, and 6. And then my mapping diagram, I'm going to list these in columns. So 4, 5, 7, 1, 2, 6. And I'm just going to use arrows to show that 4 goes to 6, 5 goes to 1, 7 goes to 2, and 5 goes to 2. So since we have these 2 arrows that start on 5, that's another way that we can say that this is not a function. All right. So questions there about listing our domain, listing our range, making a mapping diagram, and looking for repeats in the x's to decide if it's a function or not. All right, so on the second page now, it says another way to tell if a relation is a function is by the vertical line test. And the vertical line test is for graphs. So if you look on your sheet, it says step 1, we need to graph. The vertical line test works on graphs. So we have to graph this thing. And then we imagine a vertical line. Vertical means straight up and down. And it can be anywhere on our graph. The vertical line test says that if any vertical line hits it in 2 points, I'm going to say vertical line hits in 2 or more points at once, then it is not a function. So our vertical line test works on graphs. And if the vertical line hits our graph in 2 or more places at a single point, at a single time, then the graph is not a function. So let's look at an example. So we're using the vertical line test on these functions. So -4, 4, -4, sorry. That's parentheses. So our points are -4, -4, 2, 3, 3, 0, 5, 1, and 3, 2. Wait, do we know something already? We have a 3 here and a 3 there. That already tells us it's not a function. Well, let's see what this looks like if we plot this on a graph. And they have a nice grid there for you. All right, so -4, -4. That's going to be a point down here. Over 2, up 3, that's going to be a point here. Over 3, up 0, that's going to be a point there. Yes?
Alright, put 2, 3 and it's negative 2, 3.
Oh, thank you. Negative 2, 3 will be here. Five, 1 is here. And 3, 2 is there. If I draw a vertical line here, it hits those 2 points at one time. So we say it fails the VLT, vertical line test. That means it is not a function. And this would be an example, kind of going back to what we talked about on Friday. We don't connect these dots on this graph because we are just given these points. This would be a discrete relation because it just has dots on the graph. They're not connected by a line. All right, so questions on this example where a function or relation fails a vertical line test. Okay, let's look at another example. This time we're given an equation. That's our relation. We're going to make a table of values here and plot some points. So I'm going to say negative 2 squared is 4, plus 1 is 5. Negative 1 squared is positive 1, plus 1 is 2. 0 squared is 0, plus 1 is 1. 1 squared is 1, plus 1 is 2. 2 squared is 4, plus 1 is 5. So we're going to plot those points. So we have negative 2, 5. Negative 1, 2. 0, 1. 1, 2. And 2, 5. And this time I am going to connect those dots because I could plug any number in for x. I could plug a fraction in. 1.5, 2.5, negative 5.5, negative 0.001. I could plug any of those in and calculate so any of these points in between the ones we plotted would still be on the graph. So this would be a continuous relation because it has a nice smooth graph. Is this going to be a function? Yes, because I could put a vertical line anywhere and it's just going to touch the graph once. So we'd say this one passes the vertical line test. So we'd say, yes, it's a function. All right. Questions on that example? Yes?
Can you just say that it's a function because one line connects it all?
No, because you could have a graph that looked like this. If we turned this sideways, then one line would still connect it, but it would fail the vertical line test. Yes?
How did you say you got negative 2?
I picked these x values.
Oh.
I just picked them. And I just picked nice ones to calculate with. So I said, I'll let x equal negative 2, negative 1. I just picked those numbers. All right, so the last section. So we have a function here represented as y equals something. We can also write our function using function notation. Now, a lot of times students find function notation confusing because we write f of x equals, and I'm going to write the equation of a line, 3x plus 1. So we read this f of x. All this is telling us is that y, this is the same as saying y equals negative 3x plus 1. These two mean the same thing. What this is telling us is that y is a function of x. Function of x. We plug in x and we get y. So f of x is the same as saying y equals. F of x equals is the same as saying y equals. It's just a kind of a fancier way of saying that. This just tells us what the variable is that's going into our function. And our function is an equation. All right, so let's look at an example. We want the range of f of x equals 3x minus 2 if the domain is 1, 2, 3, 4. Well, the domain are my x's. So this is my x's. And I'm going to plug these in. To get the domain. Sorry, to get the range. So I'm just going to calculate with x equals 1, x equals 2, x equals 3, and x equals 4. And the way I write that is f of 1, and then I plug 1 in here. 3 times 1 minus 2. Well, 3 times 1 is 3, minus 2 is 1. F of 2 is, I'm plugging 2 in here. 3 times 2 minus 2. 3 times 2 is 6. Minus 2 is 4. F of 3, I'm plugging 3 in here. 3 times 3 minus 2. 3 times 3 is 9. Minus 2 is 7. And f of 4, I'm plugging 4 in here. 3 times 4 minus 2. 3 times 4 is 12. Minus 2 is 10. Well, this is my range. So I'm just going to write those in a set, 1, 4, 7, 10. And these are my y values. They're what I get when I plug these x values into this function. So f of x is the same as saying f of x equals is the same as saying y equals. Y is some function of x. And usually the function is given by an equation. Okay. Questions there on that function notation idea? So don't let function notation confuse you. F of x equals is the same as y equals. Now the last little note at the very bottom, it says reasonable domains. Reasonable domains just means you're picking your x values that make sense for the problem. So if you have a problem about the number of students in a class, you're not going to pick negative x values because there aren't negative students in a class. You're also not going to pick x values that are more. You're not going to pick x as 2,000 because there are not 2,000 students in this class. If your values are about the sides of a triangle, you're not going to pick negative side lengths for a triangle. So your domain's not going to have negative things in it. So reasonable domain just means pick numbers that make sense for the problem, for your domain. All right. Questions? Yes.
This was our homework, but the didn't go out. It said 4.2.
Yes, I have a worksheet. So the homework that's listed on the bottom of that page you can ignore. That's not actually your homework. Our homework is this nice worksheet. So let me stop this. Good morning, Miss Lindgren.